In this session, we're going to look at how to predict the yield of a product from a chemical reaction. Roll the graphic. Hi, I'm Paul. Welcome back. This is Science That Sticks. In this video, I'm going to walk you through how to calculate a theoretical yield of a product. Let's use the burning of magnesium in oxygen to form magnesium oxide. It's a classic, it's old school, but also it's a favourite with examiners, and you can use this process and method to determine pretty much any theoretical yield. This is for GCSE higher level students and even AS and A-level chemistry students. The process is exactly the same. So let's have a look at it. The first thing that you will need is a balanced chemical equation. So I'm going to put that on the board right now. Quite often, the balanced chemical equations are always given to you. So that's not an issue. The next thing you need to know is, what does the question ask? So let's pose the question, and that is, predict the yield if magnesium, 5 grams of magnesium, is completely combusted in excess oxygen. Well, the first thing in that question is, how much magnesium do you have to start with? Well, you've got 5 grams. You know that it's being burnt in excess oxygen. That means there's more than enough oxygen for all of those 5 grams to be combusted. The next thing you need to calculate is the number of moles that you have in 5 grams. Well, to do this, you divide it by the relative formula mass of the molecule or the relative atomic mass of the element. In this case, it's 24, because magnesium has 12 protons and 12 neutrons in its nucleus. Now, a really simple and easy thing to do is just divide one by the other, which will give us the moles. And it comes out to be 0.238, so I'm just going to round that to 0.24 moles. The other thing that you need to do is you need to work out what the relative formula mass is of the product. The numbers in front simply at this stage are a ratio of what you have with 1 to 1, or in this case 2 to 2, but because you've got 2 moles of this and 2 moles of this, whatever moles of this you start with, in theory you should have at the end. So it doesn't matter, it's not twice as much, it's just going to be a 1 to 1 ratio, because 2 divided by 2 cancels to 1. So I'm going to go to the RFM here, and that's going to be 24 add 16, and that goes to be 40. Now, because the number of moles I'm saying is 0.24, the moles of this is 0.24. Now, because moles equals mass divided by RFM, that must mean that moles times RFM is going to be the mass. And that should lead us to 9.6 grams. And that's it. That's really not that difficult. So, what are my top tips with this? The first of which is, look for the balanced equation. Look at if there's any change of numbers between the product that you've been told about and the reactant you're given mass about. If it's 2 to 2 or 1 to 1, whatever the moles is on one side, it will be on the other. Be aware of some tricky ones. You'll have to use your ratios. Know that moles is equal to mass divided by the RFM or the RAM, depending on what you've got first. And once you've got the mass, you identify that. You identify the relative formula mass. You divide the mass by the relative formula mass. Sometimes it might ask you to give the answer in so many significant figures, in which case you do so. But I'm just using some general rounding up here to 2 decimal places. I then use this here. My relative formula mass of magnesium oxide is 40. These multiply together and I end up with 9.6. That's it. That's all she wrote. That's actually not all she wrote, it's all I wrote. Until next time, stay cool. Goodbye for now. Stay cool. Bye-bye.